So the world is warming up. We now have evidence that carbon dioxide increasing is the cause of it. We're now getting into the 1970s. We're at a time where this is starting to become a concern. But how do we know where we're going next? Well, in order to figure that out, we need to be able to construct models that allow us to predict and track the next set of occurrences. So in the 1970s, we started doing just that. Now, what is a model? First off, a model is a simplification of the world around us. What I mean by that is that we can take a very complex planet with millions of moving parts, clouds, water vapor in the atmosphere, carbon dioxide concentrations, vegetation, life, urbanization, human activities, wars, and all these different things that can have an impact on our climate. And we can model them and simplify them to focus on the main forces at play. That way, we can actually make predictions for what's going to happen next. This kind of modeling is done for weather forecasts. It is done for predictions of how many people are going to die in a pandemic. Unfortunately, as I'm recording this, we're in one. How many hospital beds are going to be needed. And so these things are things that we can use to allow us to predict trends and to predict best and worst case scenarios. For climate, we use what are called general circulation models, or GCMs. Basically, what they do is they take all of the different processes that affect Earth's climate and they distill them down into a series of equations that can make predictions for the future. Now, very, very, very early climate models, models that were created in the 1970s, were extremely crude. I don't mean like raunchy, gross, or offensive. I mean, they took very few things into account. And the reason why was because we didn't have the technology in place and we had not yet had an ability to accurately quantify everything. So we really only were able to create bare bones models. The very first climate model took into account very, very few things. However, as we went from the 1970s to the 1980s, the 1980s to the 1990s, the 1990s to the 2000s, we got to a point where the world's strongest computers in the 1970s were substantially less powerful than our smartphones are today. And they were way more cumbersome and more difficult to work with. So now we are actually able to create models that include all kinds of components on Earth. But we had to start somewhere. And so in the 1970s, we started with very basic, very crude climate models. But they provided the framework for continuing to build and improve these models. Just like weather forecasting has gotten better and better. These climate models have gotten better and better over time. And so we have to be very thankful for the original pioneers of climate modeling to even get us to where we're at today. That being said, there were several models that were being developed around the world. Many different countries have their own models. The UK Hadley Center has its own model. The Japanese Meteorological Agency has its own model. The French have their own model. The Chinese have their own model. Brazil has their own model. They all have their own models. The United States, our climate model is what's called the Community Earth Systems model. I actually had the honor of working on it for my master's thesis. I worked on just one small component of it. But that just goes to show how complex the model is today. Here in the United States, the two pioneers of climate modeling were these two gentlemen by the name of Warren Washington and Akira Kashihara. Warren Washington and Akira Kashihara. They worked for the National Center for Atmospheric Research, NCAR, which is actually where I interned there to work on the Community Earth Systems model. And they put together the very, very, very basic bare bones models in the 1970s. Here are some pictures of these two gentlemen. Akira Keshihara here on the left-hand side, holding different reels of data on them. Again, this was back when computers were very, very, very crude compared to what they are now. I mean, if you think all of those reels of data had this compared to the hard drive on your phone. Um, and then over here, Warren Washington and one of his students, Brenda Chester, were working on and analyzing data in developing these models. Um, One cool thing that I kind of get to brag about is I actually met Warren Washington in 2011 at a conference in Colorado. And here he is here. He's actually holding up a picture of him receiving a Medal of Honor from Barack Obama. There is a young me. My gosh, I look so much like a baby in that picture. And then this gentleman over here is a good colleague of mine and good friend. His name is Henry Bartholomew. He teaches meteorology at San Jose State. If you're ever looking for a good class, take his MET 112 Global Climate Change class. It meets upper division GE requirements. Uh, Really, really cool guy. He was actually in my wedding, a really good friend of mine. Um, and yes, I had the honor of meeting Warren Washington. And so that was actually really cool to actually share that. That being said, the very, very early models had very few things they could take into account. Um, Mostly just carbon dioxide, rainfall, incoming sunlight, and that was about it. However, as time went on, technology allowed us to start including things. And scientists from different communities, from geography, geology, oceanography, from biology, ecology, all of these different scientists were able to actually take their components of our Earth system and quantify them and integrate them into these models. In the mid 1980s, we were able to add the land surface, which greatly influences what the Earth does with sunlight. Then we were able to include clouds. Eventually, we were able to include an ocean, a very, very swamp ocean, but an ocean nonetheless. We were able to include ice. Eventually, we were able to include volcanic activity, other types of pollutants such as sulfites, aerosols. We were able to start turning the ocean into a more accurate depiction of the ocean using global ocean currents and overturning circulations. Um, Aerosols, tiny little solid particles in the atmosphere, and then eventually ocean chemistry. So each and every one of these different components, we were able to, over time, integrate into these climate models. And all of that said, this is where we're at now. You don't have to stare at this like a deer in the headlights, and you don't have to memorize all of this, but I just want you to see it and just get kind of an idea that the current modern day models are way more complex than they were even 30 years ago. And they include way more components of our Earth, not just clouds, but different types of clouds. Um, Not just precipitation, but evaporation, exchanges with the atmosphere and the ocean, life is involved in here, vegetation, glaciers, rivers, lakes, and streams, land surface processes, the geography of our planet. We were able to basically take all of these individual components of our very complex planet and integrate them into these models. So, any of you who are computer scientists or any of you have had any experience with modeling know that this is probably a very complex model. And yet, this is still a very, very, very simplified version of our planet as a whole. Um, and we can use these models to then make predictions for the future. Now, that being said, how do we know that these predictions are even accurate? Well, the way that we know about them, and before I go on, you can find more information about climate models using these sites right here. There's some really good sites. But how do we know that this is even accurate? Well, what we do is we have these climate models reconstruct past climate, past day to day changes in weather patterns, past changes in our climate, and compare it to what actually happened. And while they're not perfect, they actually do a really good job at it. Now, that being said, as time has gone on, we have been able to better predict Earth's future. Now, how does Earth's future look like? We're going to talk about that in our last video for this module right after this.